This is how to make your code last. And I'm happy to say that, I talked about it with all the principal developers, and these were unanimous. So we think this will help you if you write code. I'm going to start with a little theory, because in theory, there's no difference between theory and practice, but in practice, there is. So I'll start with some definitions, because good definitions make for clear ideas. I want to talk about refactoring, porting, and optimization. These are 3 different techniques of rewriting code, but they're not mutually exclusive. Sometimes you can refactor code and it's optimized too. So we refactor code to reduce code smell. Code smell is a real thing. It's an industry term. It's not something I made up. It's when your code isn't quite right. It doesn't have any bugs, but it's very messy, it's hard to read, or it's not efficient. It's kind of like that bag of broccoli that's in your fridge that's about to turn and it smells like a old dish rag. Something needs to be done. So refactoring code is restructuring code without changing its external behavior. The term comes from mathematics, where you want to know what the factors are of, say, a number, right? So we can get to 12 by multiplying 2 times 2 times 3, or 3 times 4, or 2 times 6, or 12 times 1. And the output is all the same, 12. That's what refactoring does. You're changing the factors without changing the answer, right? It makes code more readable. You change its design to make it more efficient, and it reduces complexity, right? In data science, you shoot for tidy data. In software engineering, you shoot for elegant code, right? The cleaner the code is, the longer it's going to last. It's going to be fresher longer. Porting code is different, right? This is rewriting code to run in a different language or a different environment or on a different platform, right? The focus is on compatibility, not changing the core logic or behavior of the program. This is what we did with Entourage. Connor wrote the code for Entourage in VBA, Visual Basic for Applications, in Excel, and then we gave that code to Dan, who rewrote it in JavaScript. He ported the code. He made it more portable to run in different places. So that's why it's called porting. And last but not least, we have code optimization. This is rewriting code to make it more efficient. Maybe you want to make it run faster, or use less memory, or reduce bandwidth. This improves scalability. There's a saying, though, that premature optimization is the root of all evil. Don't optimize code prematurely. Wait till it's an issue, so you don't end up wasting time on something that ended up being insignificant. When I worked at the Apple online store website as a software engineer, we would take the website down, and then Steve Jobs would walk on stage and announce all these new products. When he walked off stage, we would have to turn the store back on under a huge load, because everyone was going to the store and putting items in their cart. So what we would do the week after is all the engineers would gather around with the logs, and we would look at the logs to see where were we most constrained. Were we CPU constrained, bandwidth constrained, memory constrained, disk IO constrained? And then that's where we would focus our optimization efforts to improve that for the next keynote. I'm going to go through 10 tips for improving your code. I'll go through them real quick. Most of these you can do right now moving forward. Some might require a tool or outside help. So for starters, when you write a file, when you have a file with computer code, try to keep it less than 300 to 500 lines of code. Here's a program that we have in our repository. It's been around many years. We've kept adding to it, and it's over 3,800 lines of code. So this could be shortened. In this one file are 20 high-level function definitions, and then 4 more functions are defined, nested inside those functions. And you kind of get a little bit of anxiety when you open this file and you see here in the mini map, which is a bird's eye view of your code, it's extending to the bottom of the page and it's very squished. So less than 300 to 500 lines of code. And this makes it easier to debug. Once you do that, then here we have a fictitious class 10 calculator that takes an array of file names. When you use fewer lines of code in a file but spread it out across files, then you can just call these functions as needed, and it's almost human readable by someone who doesn't understand coding. Here you can see we read the class 10 files, we parse it, we do the calculations. So less than 300 to 500 lines of code. One way to do that is by creating functions or methods that are less than 50 lines of code, right? This prioritizes both readability and simplicity. I'm very fond of saying that true simplicity lies on the other side of complexity. A big part of software engineering is managing complexity. If you do not understand all the complexities involved in the problem you're trying to solve, you may end up coming up with a solution that is either oversimplified or over-engineered. So you have to understand the complexity before you simplify. When you create functions, follow the single responsibility principle. In other words, make a function do one thing and one thing only, and then you can link together the functions, right? You know you're getting away from that principle if you're putting the word "and" inside your function. Get data and process results. That should be get the data and then pass the data to a function called process results. Makes it more readable. Also, avoid multiple nested if-thens or for loops. Don't indent tabs. Don't tab in more than 4 tabs. For one reason, it'll cause your code to go off the screen, which is hard to understand. This code example is nested 7 levels deep. And right, the first line here, we're checking to see, is the data null? What do we do? What's the else to that? Well, you have to manually, with your eyes, scroll down, which might be off the screen, to see what the else part is. Way to avoid that is to return early. So here's same, very similar code, but in a different technique. So here, if the data is null, just print this message and then immediately return, so you know exactly what's happening. If the number of rows is 0, print this message and return. The same thing, if the column names don't have a column with the name status, print this message and then return. And then this entire file, you can see, is much, much shorter from this bird's eye view. So there's not a lot of code here that you have to sift through to figure out what's going on. If you find yourself copying and pasting the same code you wrote maybe on a previous project with minor tweaks more than 3 times, that's a hint that that is valuable code. So take that and refactor it so that one section of code will work in all those cases. This makes your code shareable, it's easier to maintain, it's more readable, and you end up with a smaller code base. Minimize global variables with one exception. Right? The problem when you use global variables is people can misunderstand what that variable means because someone else created, so you end up with collisions. It's easier to debug when you don't have a lot of global variables. It removes hidden dependencies, and it's easy to reuse. Right? Ensure your variables go out of scope when they're no longer needed. You don't want to create a global variable that has 1 million rows of data if it's not going to be used, because it takes up a lot of memory and slows things down. The exception are string constants. String constants should be global variables. I'll show you an example of that in a couple slides. Don't hard-code credentials or SQL in your code. Right? Credentials like all logins and passwords should be put in an environment or config file, not in your code. The config file should never be checked into the repository. Right? If your repository is hacked and there's no credentials in there, you don't have to worry about credentials to other systems being compromised. SQL should be put in SQL scripts or stored procedures in the database. Don't hard code SQL in your JavaScript or in your R code or Python code. Now, the thing about the credentials, I've got the scar tissue to prove this. This is my personal Amazon account, and typically it was about $6. And on April 10th of 2014, I logged in and I had a $5,000 bill at that point. I was on track for a $15,000 bill. I called up Amazon. I asked them what happened. They said, your credentials, AWS credentials, were probably compromised. I said, how did that happen? They said, you probably checked it into GitHub. So what I probably did was, here's an example of some AWS credentials. They always follow this format. The key ID is always 20 characters, and the secret access key is 40 characters. So hackers end up going through GitHub repositories looking for a pattern of 20 and 40 characters. Now, I did not these credentials were actually put into a config file. So I did that, but what I ended up doing was not deleting this code. Instead, I just commented it out so it wouldn't be executed, but it was still in the repository as commented non-executable code. So that was a tough lesson. Actually, an article was written about what happened to me. If you ever want to see it, you can just double click on this image and it'll take you to the full article. Okay, I said don't hard code credentials. Do hard code strings as global variables. And here's why, right? It's to prevent typos. So here we have AAC, activity address code, as a string. So let's say later on, instead of typing AAC, you type ACC. That will compile. It will probably pass test. It gets deployed into production. And then you end up with a very weird bug that takes some time to track down. Instead, create a global static variable or maybe a global constant, and that variable name would be AAC, and it equals the string AAC. Then here, instead of putting the string AAC, you put the variable AAC. Down here, if you accidentally type the variable name as ACC, the compiler will immediately catch that and say, I don't have a definition for it. You'll catch your error before you've even compiled the code. So over here, yes, American, yes, different definitions. Use AI for coding. GitHub offers Copilot for free and paid. And this was rather amazing when Aaron brought it to my attention in the fall of 2023, because you could just put comments before a function that describes what the function was going to do, and GitHub would auto-complete that function with a version that was pretty close to what you wanted. Also, you can take code and probably paste it into most any LLM and ask for coding suggestions. And then finally, if you use a CLI, a command line interface, like Terminal on Mac OS or PowerShell on Windows, instead of using that, I'd recommend using Warp. Dan pointed this out to me, and Warp has AI included into it, and it does a lot of very impressive things. Having AI, even at the command line, can do a lot for you. Debuggers. If you do not code in a debugger, I highly recommend using it with your integrated development environment. It allows you to set breakpoints, it allows you to step through code, and it allows you to examine variables. And I'll give you an example here. Chris Cicci wrote this code, and we were pair programming and debugging it in debug mode. And the way you use a debugger is first, the line of code that you want to examine, you double click here in the gutter, and you'll see a circle show up. And that tells you there's a breakpoint set there, which means that the IDE will pause on that line of code. Then instead of hitting run to run the code, you click debug, right? If you click run, it ignores breakpoints. If you click debug, it honors them. So here you see on line 2, there's a console.log that says this is a test1 message. So here in the screenshot, if we go down to 3, we see line 2 was just executed, and it said this is a test1 message. And now the IDE is waiting for your next instruction. You're on this line of code. What do you want to do? Do you want to skip over it? Just hit play, and it will continue executing your program. Or you can step over each line of code by clicking this repeatedly. Now let's say you wanted to see what console.log does. You want to see what that function does. If you have public access to that, you hit the down arrow, and it will take you down into that code for that function. And when you want to come back, you hit the up arrow, and it'll pick you back. It'll put you right back where you were. So that is a debugger. I highly, highly recommend them for coding. And I always recommend just running in debug mode. It saves time. Operations costs, get an idea of what a line of code costs in terms of time or resources, right? There's this formal computer science discipline called Big O notation. It stands for order of magnitude of growth. Instead, I'll just give you some easy practical examples, right? Use cheap, inexpensive operations that run fast. A hash table is a great example, because a hash table, to look up something in a hash table, takes the same amount of time, whether you have 1,000 elements in it or 1,000,000. And it's the same thing with an array by index. You can just say, give me the object at index 500 or 5,000 or 500,000. It'll return just as quickly. These are very fast operations for managing data. On the flip side, know what's expensive, right? These are slow operations. Sorting is always expensive, right? It will take much longer to sort 10 million items than it will 1,000. Nested loops. Loops can become very expensive very quickly. If you nest 3 different loops that count to 1,000, for I equals 1 to 1,000, for j equals 1 to 1,000, for k equals 1 to 1,000, that is going to grow exponentially. You're going to loop through those loops literally 1 billion times. And then network operations are inherently slow due to the latency of the network, especially web API calls. When you make a web API call, I highly recommend setting up a network timer to time how long that lasts. And I'll show you to do that in a moment. Solve expensive operations by caching the results when you get them back. To set up a network timer, this is the expensive line of code, line 3. It could be processing a credit card with a credit card processor. We've all done this on an e-commerce website. Sometimes it takes 5 seconds. Sometimes it takes 50 seconds. As a software developer, you want to know how long it took. So you start the timer, start a new timer, and then you output to your log when you started. You do your expensive network e-commerce operation. You stop the timer. You print out the stop time. And then most importantly, line 6, you print out the elapsed time. And then you can analyze this over time to see how long operations are taken. And then finally, use a linter. This removes the lint from your code. A linter is a static code analysis tool used for flagging errors. It's static in that it will work in real time as you're typing it. You don't have to build or compile your code to see it. These are the different linters that you can use with different languages. And finally, use these coding tips for future work. Don't go back and start refactoring and everything unnecessarily unless you're actively adding code to that function or the code smell is unbearable. And then today, Lisa reminded me, don't hesitate to call a professional. All of the principal software developers, the data engineer and software engineers have decades of experience and they have the scar tissue too. So that concludes this. Thank you.